Hi, welcome to review for the M2T1 test, the Module 2 Topic 1 test. We're at the end now already. So we're going to be doing rewriting explicit formulas in slope-intercept form. It's been a while since we've done explicit formulas, but in particular, we're doing the one with the A. Remember, that means arithmetic, right? And this meant we start at -5 and then we add 8 every time, right? So -5, add 8, so that would be 3, and add 8 more, that would be 11. There we go. Again, try this yourself. And if you don't remember how to do this, then you look, or if you after you've done it already, then you see my steps and see if they kind of line up, right? And remember, we want it in slope-intercept form. So if you remember, slope-intercept form is just y equals mx plus b. If you notice right here on for number one, doesn't really look like that. Instead of an x, we do have an n, so we do have a variable, but notice we have these parentheses. So how do we get rid of these parentheses? We got to distribute. So we're going to distribute this plus 8 with the n, okay? But before we do that, I'm going to actually write the things that we haven't used yet. So we're not using the an, so we're just going to write an is equal to, haven't used -5 yet, so I'm going to just copy that down. Now I'm going to distribute 8 times n, which is just plus 8n. And then I'm going to distribute 8 times -1, which is going to be -8. All right. And then the second step is combine like terms. So now we have no more parentheses, and now we're going to make it look like this form. So we're going to have an is equal to, we're going to start with our variable first. So our variable is this, did I say 8n? I meant an. And then that's going to be 8n. And now we're going to do our plus b, which is just our y-intercept, which is going to be our -5 minus 8. So that's going to be minus 13. All right, we're done. That's all there is to it. So this is our answer. It's now in slope-intercept form. So now we know that the slope is 8, right, which is the same thing as our common difference. And our y-intercept is at -13. So remember, this was the first term. So if we're going to go 8 previous to that, that we would have started at -13 for the y-axis, or the y-intercept, I should say. Righties. Now, again, it's just 2 steps. So we're going to do the same thing for this second problem. I'm not using an, so I'm just going to copy that down. Equals, we got 10. And then we're going to go, remember this is a -4, so think of it like a -4. So -4 times n is going to be -4n, or we should say -4n. And then -4 times -1 is going to be +1. Remember that negative cancels out the other negative. Two negatives make a positive, right? And now we're going to do our second step, which is just, let's write the answer down. So an is equal to, we're going to start with our variable first, so -4. A lot of people, they forget that negative. Yeah, that's why they would get it wrong. And then 10 plus 1, which is going to be plus 11, right? And then we're going to go on to number 3. Again, it's a 2-step process. Let's try to keep the colors the same. So we got an is equal to 5. Now we're going to distribute that 2. So 2 times n is going to be positive or plus 2n. And then 2 times -1 is just going to be -2. All right. You don't have to make these marks, but it's just to help you to remember what you're multiplying with. And then we're going to combine like terms. So an is equal to, start with a 2n. And then 5 minus 2 is going to be plus 3, a positive 3. So we're going up by 2, and we're starting at 3 on the y-intercept. All right, last problem of these. Again, we're going to write in the an equals -7. The more you try these out, you'll see it's the same thing every time. -3 times n is just -3n. And then we're going to multiply -3 times -1, which is going to be +3. Now, we did our distribution. We have no more parentheses, so we're going to go straight into combining like terms. So we're going to go -3n. Forget that negative. That minus, think of it like a negative, right? And then -7 plus 3, which is going to be -4. So an is equal to negative 3n minus 4. Okay. There we go. That's the first one, changing explicit formulas to y-intercept form. And then we're going to go into the next one, which is determining whether these tables are linear functions or not. And if it is a linear function, then we're going to write down the function. If it's not, can't write down the function, right? It's not linear. There you go. So we've got this table right here for number 5. We have to check the slopes. The way you can find that it's linear is you got to check the slopes between all the points. If we knew it was linear, then we only need to figure out the slope by using 2 points. But since we don't know that it's linear, we need to make sure it's going up at a constant rate or going down at a constant rate. And so here we go. The y difference is it's going from 2 to 4, 2 to 6, which is we're adding 4, right? And then what is the x doing? Is going from 3 to 5, which means we're adding 2, right? And then let's try this with a different color. So let's try this. So from 6 to 10, we're adding 4. And then from 5 to 7, we're adding 2. So far, so good. So we're going up 4 and then to the right 2. Hopefully for you, this is the right 2. If not, maybe it's this one. Yeah, I don't know how it works over here after I finish recording this. So this is 10 to 14. So we're going from 10, then going to 14. So that'll be 4, right? So if these are numbers that you don't know, then you could just, another way that you could do it is go 14 minus 10, and that would give you 4. See, same answer. And same thing here, 7 to 9. So we're adding 2 every time. So if you notice right here, between all the points, it is going up the same amount, or the same ratio, we should say, right? So up 4 over 2, up 4 over 2 every single time. So you know this is a linear function. So I'll be like linear function. And let's write down the function. And remember when we said about function, we need function notation. So we're gonna, the most common one is f of x. So f of x, not fx, f of x equals, and then we're gonna use our slope. So our slope is, how much did we rise? We went up 4, and then we're going over 2, right? So to the positive direction. So this is gonna be, and this one we can actually simplify. So it's 4 divided by 2, which is just 2. So that's going to be my slope. And then we're going to figure out the y-intercept. On the table, it doesn't give you the y-intercept, because how do we know if it's a y-intercept? It's when the x is 0, right? So we're going to kind of go backwards. We know if we go back 2, so we're going backwards 2, which means that that's going to be, instead of 3, that's going to be 1. And then we're going to go back 2, or sorry, back 4, right? Because the y's are going back 4 every time the x's are going back 2, which means that's going to be from 2, we're going to go back 4, so it's going to be negative 2. So that's for 1, but we want it for when x is equal to 0, right? So we're going to make this 0. So which means if we go back only 1, right? So we're going back 1, we have to go back half as much as the 4, right? Because half of 2 is 1, so half of 4 is 2. So we're going to go back 2. So negative 2 minus 2 is minus 4. Think of it like going back in time, right? What that would look like. So, yep. So we would be starting at 0, negative 4. So that would be our y-intercept. Okay, so don't forget our x, and we're going to go minus 4. So again, our slope is going to be here. That's our slope. And then our y-intercept is going to be from this guy right here. That's a little too big, don't you think? Let's make it a little bit smaller. And so this is our y-intercept. When x equal to 0, the y value, the y coordinate, that's going to be our y-intercept. So that minus 4 is going to be this minus 4. And sometimes the table will give you the y-intercept, and sometimes it won't. So if it doesn't like this, then you're going to have to figure it out. Okay, so there is our answer. Boom, just like this. All right, let's try this for number 6. All right, for the y, we're going from negative 5 to negative 10. So we're going more negative, right? So we're going to go down by 5, and then the x is going from negative 1 to negative 2. So we're going more negative, right? So we're gonna go down by, go to the left by 1, right? Let's try that again for the y. So -10 to -20, we're going down by 10, right? Which may not be a problem. It just depends on what the x is doing, right? But do you see how the difference for the y is doubled? So that means the difference for the x should double as well. And if you look at right here, -2 and -3, that is still going down by 1, which means this is not linear because we're not going at the same rate, right? So in order for this to be linear, this should have been a 2, right? Since we doubled our y difference, so then we're going to have to double our x difference. So since we did not do that, we would just say, we would stop right. We don't even need to go on. We would say not a linear function. Just like that. Not a linear function. And then we just go on to number 6 or number 7. All right. Let's go just like this. So let's take a look here. So we're starting at -5. We're going to -3. So we're becoming less negative, which means we're going in the positive direction. We're going to go +2. So y is going up by 2. Well, what's the x doing? Starting at -10 and then going to it's getting more positive, right? So it's going to the right 5. So we're going 2 up, right 5, right? And let's just see here. This is going to be -3 to -1. So it's, again, up 2. And then what is the x doing? Yep, we're still going up 5. So far, so good. Let's see if this one will make it linear or not. So this is from -1. We're going to 3, which means we're going up 4. Okay, so it's a warning sign, but we just need to make sure. So we've just doubled our y. And if we're doubling our y difference, then we have to double our x difference. So this other one should be, instead of going to the right 5, it should be going to the right 10. Let's see if it does that. So it says from 0 to 10. Yeah, that's 10. So we are going to the right 10. So it's doubled, so it does maintain its constant speed, excuse me. So here's m is equal to 2/5. And just so that you can see it, I'm going to just do the same thing for the bottom one, because it's 4/10. See, 4/10, which means we can simplify it, right? What can we divide both of those numbers by? Since they're even, we can divide them both by 2, right? So 4 divided by 2 is 2. 10 divided by 2 is 5. You see how the fraction still is the same? So it is an equivalent fraction. It's just larger numbers. But when we simplify it down, it does remain as 2/5, which is the same fraction. So we're good. So it is linear, and so let's write down the equation. So, or the function, I should say. F of x is equal to our slope, which is, let's make that orange, 2/5. X. Please make sure your X is right next to your bar, not below. So if you put it below, that's a whole different kind of problem. It's an algebra 2 problem. We're not there yet. And then we're going to do our y-intercept. Let's look for a y-intercept. And if you notice right here, ba-bam. I don't know why it's so big. Let's go like this. So here we do have an X of 0, which means our y-intercept is -1. So we're going to be like -1. Okay. So this guy right here is that y-intercept. Same thing. Okay. And remember, our slope came from the differences in the y's and x's. All right. There we go. There's our equation. Okay. Number 8. Let's take a look. From 6 to 4, our difference is 2. We are going down, so we're getting smaller, so it's -2. And our difference of x's are going to be from -6 to -3. So we're going less negative. So we're going up by 3. And again, here we're going down to, we're getting smaller and smaller for the y's, and the x's are getting bigger and bigger. So that's so far so good, right? We're going down to right 3. And then this is again going down 2, and we are still going to the right 3, right? So our slope is going to be 2/3. You thought I forgot the negative, huh? Nope, there it is. -2/3. Because the y's are negative, the x's are positive, that's going to make a negative slope. All right? Because remember, it's going to be decreasing, going down. Okay, so now we need to find the y-intercept. Which one is the y-intercept? I notice that there are two zeros here. I have a 0 for the x and 0 for the y. Which one is the y-intercept? The one where the x is 0. So this guy right here, that's going to tell us. Because the other one, that would actually be the x-intercept. We're not looking for the x-intercept. We just want the y-intercept. Okay, so let's write this out. So f of x is equal to our slope, which is negative 2/3. Change that to purple, x. And our y-intercept is, oh, do I have yellow? I don't think so. Let's, do I have yellow? Yeah, I do. I believe you can see this. It's gonna be, so it's a positive 2, so it's gonna be +2, just like that. Boom. All right, got two more of these. Again, please practice. Try it out. Don't just copy me. A lot of people just copy me and thinking, oh yeah, it's going in my brain. No, it's not. Right? You need to actually do it yourself. Your brain needs to work itself out, right? Take off the training wheels. You can do it. Okay, so I'm gonna just scoot this up just a tad. All right. I'm assuming you've tried this already. If not, pause. All right, from starting at 3, going to 6. So we're going to add 3. Because we're going up 3. And then what are we doing for the x? From 1 to 3, we are going up 2, right? So up 3 over 2. Let's see about right here. So we're, oh, from 6 to 12, we just doubled it. So we're going up 6, which means we should double the x. So let's see if that we do that. 3 to 5. That's just up 2 again, right? So you see, the y difference is doubled, but the x's stay the same, which means this is not linear. So we're going to have to stop right here and be like, not a linear function. It is a function. It's not a linear function. So therefore, we cannot write a linear function. Last one. So x is, oh no, y's are going from 8 to 4. So we're going smaller. So we're going subtracting 4. And then what are the x's doing? It's going from -5 to -1. So we're getting less negative. We're actually adding 4. Okay, so down 4, over 4, or to the right 4. And then here we go. 4 to 2. Ooh, this is a different number. This is going to be like number, oh, wait a minute. Do you see what I see? Do you see this is number 9? This is number 9? That's a big problem. That's 10. Sorry, guys. And so the difference is for the y's now half as much. So the difference for the x's should be half as much. So this should be a +2 next. So from -1 to 1 is actually +2. It's so good. If you're like, no, Miss Lee, it's just 1. Don't forget the 0. There's a 0 in there. So it is actually a distance of 2. All right. So then that works, right? Because we cut it in half on both the x and the y's. So now we're trying this last difference. So we're going from 2 to -1, right? So it's from 2 to -1, which is going to be -3. Well, then what's it going to be here? We're going from 1 to 4, which is going to be +4. Are these all the same slopes? Let's find out. So if we do the first one, is -4 over 4. And some of you guys are like, Miss Lee, I already know the answer. That's fine. Some people don't, so I'm just going to explain it. So what's -4 over 4? It's equal to -1, right? And then same, so this is equal to -1. So let's try for -2 over 2. What's -2 over +2, right? Same thing. 2 goes into 2 one time, right? And then one of them is negative, so we got -1. And we'll try this one more time. -3 over 3. What is -3 divided by 3? Still 1. Oh, sorry, -1. Still -1, right? So the slope is -1. So even though those numbers were different, they were different by the same amounts, right? So they increase and decrease similarly or proportionally. So we're good. So it is linear, so we're going to write a function. So f of x is equal to our slope, which is -1, x, and then our y. Ooh, we don't have our y-intercept. So we need to find it. So we know it's going to be somewhere in here, right? It's halfway between from -1 to 0, -1 to 1. The halfway point is 0, right? So from 2 to 4, what's the halfway point? 3, right? There we go. It's done. And another way you could have done it is we know that the slope is -1. So every time y goes down by 1, x goes up by 1, right? So if you look at 4, it's going to go down by 1, which is 3. And for the x, it's going to go up by 1 from -1, which would be 0. So we know our y-intercept is going to be 3. It's going to be plus 3. And normally how we would write this, because we don't normally write -1x, we would just say, I mean, it's not wrong. It's just, we try to minimize. As mathematicians, we try to minimize. So we would rather you say -x plus 3 as opposed to -1x plus 3. Got it? Capiche? All right. We're going on to the next one. Number 11. Try this out. We're evaluating functions. So we've been working on these, and if you're like, I don't remember, this is when we practice, right? So f of x is equal to -4x plus 5. So notice we want to evaluate for these two functions. Okay, so we're going to do these two functions, these two numbers. So this is f of -3. Notice that instead of x, we put in -3, which means anywhere we're seeing x, we're going to replace it with a -3. We want to know what is the answer when x is equal to -3. Instead of writing that all out, we just said, what is f of -3? So yeah, that's less verbose. And so we're going to do that. So we go -4. Now instead of x, we're going to put in -3 plus 5. So I'm going to be like, here's my highlighter, here's my x, right? And this is what my x is. That's the only thing that changed, are the x values. That's it. Now we're going to use the order of operations to evaluate these. And normally this parentheses, remember, means multiply. So we're going to go -4 times -3, which is going to be 12. And then we're going to add this 5. We did not do that yet. So now we're going to do it right now. 12 plus 5 is 17. Woo! So that's our answer. All right, so when x is equal to -3, y is equal to 17. We could have graphed it, but do you really want to, as you say, it's a lot. And then I'm going to do B. So this is, notice instead of, no, it's a decimal, but it works exactly the same way, right? So we're going to use the same function. So this is f of x, so this is f of 2.3 is equal to -4. And instead of x, we're going to put in 2.3 plus 5. Sorry, that should be lower right there. And then you can use your calculator, whichever way. You can use your brain. You can use your multiplication tables, right? And then, so -4 times 2.3 is going to be -9.2 plus 5. Leave this now. I'm pretty sure it's right. Let's carry one. Okay. And then -9.2 plus 5. So that's going to be -4.2. All right. That's it. Same things. Use your calculator, right? Because normally decimal points, I'm not asking you if you know how to multiply. I'm asking to see if you know how to do the work. If you know how to evaluate these functions, right? So please make sure you know how to use your calculator. Use your tools. All right, we're going to do the same thing now, but we have g of x. And g of x is 6.3x minus 2.1. Ooh, so fancy. And here we go. Now we want to evaluate for g of -10. So instead of x, oh, that down again. So we got g of -10 is equal to 6.3 times -10. Right, we're replacing the x minus 2.1. Do not let the decimals throw you off. They're just numbers. Decimals are numbers too. So 6.3 times -10 is going to be -63, right? Minus 2.1. And -63 minus 2.1, so we're getting more negative. So that'd be -65.1. That looks awfully strange. -65. There we go. Just like that. And we're going to try for the last one. Ooh, we got decimals for days. So 6.3 times our x is now 12.3 minus 2.1. Okay, I'm going to have to bust out my calculator for this one. I can't do this one in my head. So 6.3 times Let me see, calculator, come on. 6.3 times 12.3, and that's going to give us, 77.49. We're not going to have to round on these, just keep them as is. Okay, no rounding here. And then now we're going to subtract 2.1 from it. Ooh, I can do this. 75.29. There we go. Happy days. And again, decimals are just numbers. Just treat them the exact same way. You still multiply them and then subtract whatever or add whatever the last number is, right? That constant. All right, that is evaluating functions. Now we're going to go with some writing functions given a scenario, right? Given a story problem. So Timothy has some diamonds, but of course he wants more, right? He wants more. He's gathering diamonds at a constant rate each minute. This is probably not in real life, probably in Minecraft, but I don't know. Maybe he just found a place where a whole bunch of diamonds are. He got super lucky. So he gathers diamonds at a constant rate each minute. The table shows the amount of ore that Timothy has for various amounts of time. So we know after 1 minute, he has 23.5 grams of diamonds. That's a lot, but he wants more. After a minute and a half is 30.75 and so on and so forth, right? And it says write a function that models the table of values. We already know that this is constant rate, which means that it is linear. So we don't have to check every single one. We just need to check one, or just check 2 points to find the slope so that we can, what is it? So we can find what the slope is. All right, so I'm going to pick some that are like, I'm going to pick one that's close together. So I know normally we want to stay away from decimals, but I know it's from 1.5 to 2.5. That's a difference of 1. So I like to divide by 1 because it's easy, right? So I'm trying to make my life easier. So I'm going to be like, okay, well, I know we're going up by 1 here, okay? From 1.5 to 2.5. Here it is from 3.75 to 45.25. I'm gonna need my calculator for that one. It's like 14 something. Okay, so 45.25 minus 30.75. I hope you're doing this too. Don't just wait for me. You try it out too, right? And then, some people ask, Miss Lee, why are you so good at math? Why are you so good at algebra? I'm like, because I do it every year, right? If you were doing Algebra 1 for you were teaching it for many, many years, wouldn't you be good at it too? Would hope so, right? So there we go. So it's 14.5. So we get 14.5 grams every 1 minute. I feel like that's quite a bit, right? Maybe he has enough for a diamond armor. I don't know. Yes, so 14.5. Tim is a very lucky guy. So we know that the slope, so I'm just going to write it out here so I don't forget, is 14.5 over 1, which is just 14.5. It's a good day. We need the y-intercept because remember it says that Tim has some diamonds but wants more, which means he started with some diamonds, right? But we just don't know how much. We're going to go back in time, rewind time to 1 minute before. And what was it? So remember, if every 1 minute he gets 14.5, we got to go back in time. We're going to subtract that 14.5 from 23.5. And that's how much he would have had originally, right? And so 14.5 minus 23.5 minus 14.5, that's going to be a whopping 9 grams. Okay, and if you don't believe me, do it on your calculator. Figure it out. 23.5 minus 14.5. And then here we go. Let's write our functions. So we can do this whatever letters we want. We don't have to use f of x. I'm going to do D for diamonds, right? So D for diamonds, and then M for minutes. You can do however way you want to do it. You can use, if you want to still use f of x, totally do that. I'm going to be like D of M. All right, and then so we're going to have our slope, which is, we made it purple, so I'm just write as purple, 14.5 x, and then our y-intercept is plus 9. We start out with 9 grams of diamonds. And then every minute he's getting 14.5 more. That's why you need the X, because we don't know. Oh, did you see my mistake? It's not an X. Because what did I say my independent variable was going to be? M for minutes. Sorry. All right, so that makes more sense. So this M has to be the same thing as our independent variable. So they should be the same. You can't have an M and then a random X here. That doesn't make any sense. That's not function notation. That would you would get that wrong. All right, so we are going to define our variables because it says so. So M is, I like to do a little colon here. M is number of minutes. And our D of M is, do you see, I'm going to just like copy this down. Weight of diamonds mined. Well, weight of diamonds actually altogether, right? So in grams. There we go. Done. Now it has determine the total weight of diamonds Timothy has if he's gathered diamonds for 15.6 minutes. Yeah, I see I can't do that in my head, and we can't even do this on the chart because can you imagine trying to do it? No, I'm not doing it. We're not going by 0.6. So we're gonna do this. We're gonna be like D, and we know the M, right? We want we said that the M was going to be 15.6, right? So we know the minutes is 15.6. And so we're just going to write this out. So 14.5 times, well, what is our minutes? We already know that, right? That is 15.6. Remember the evaluating functions? This is the same thing. Okay, it's just in context, right? And then our plus 9 right here. So then we're going to have to figure this out. So get my calculator. Get your calculator. Calculate it out. Don't wait for me. Don't be lazy. You can do it. So 14.5 times 15.6 is 226.2. That looks weird. That's fine. Plus 9. Don't forget, we didn't do that yet. Then I'm going to add 9 to that, and that's going to be 235. So 235.2 grams. That's a lot of grams. Maybe he can make his diamond armor now. I hope so. All right, now we're going to talk about Josiah. So Josiah is mining moonstone. What is moonstone? I'm not sure, but it's probably stones that are from the moon. I don't think this is not a Minecraft thing, I don't know. But regardless of which, right? So he's again mining at a constant rate. So we know this is definitely going to be linear. Let's pick something that would be ooh. Let me just pick the first one because 2.5 to 3.5 again, that has served us well. There's a distance of 1 or difference of 1, I should say. So we know, so divided by 1 is always nice. And then 38.5, so we start at 27.5 and go to 38.5. So that's, so the 0.5s, I subtract it, it cancels out. 38 minus 27 is going to be 11. So I'm increasing by 11 pounds, not I, Josiah. Josiah is getting 11 pounds in 1 minute. Is this realistic? Who made these questions? Definitely not me. I'm just kidding. It was me. I'm sorry. I don't know what I was thinking. So 11 pounds in 1 minute, which means that is just 11, right? Because 11 divided by 1, just 11. And then we need to figure out the y-intercept. We need to go back in time. Okay, let's see. If we go back 1 minute, which would be 1.5, right? Then that we would go back 11, right? Which would be 27 minus 11 is going to be 16.5. Then we're going to go back another minute. So that would be at 0.5. Go back another minute, and that would be minus 11 again. That would be 5.5. 5.5. Ooh. And then we're going to go back to 0. So that's half a minute, right? So what's half of 11? 5.5. If you didn't know that, use your calculator. 11 divided by 2. Okay. And then we're going to go back 5.5, which means what's 5.5 minus 5.5? That's a 5. It would be 0. So Josiah actually started with nothing. Okay, so that's good to know, right? So here we go. So we're going to write the function. So that's going to be, let's use Moonstone for amp. Okay, now you know what? Let's just use f of x, right? Because just to show you that we can do it, doesn't matter. So f of x is equal to our slope, which is 11, x, and then our y-intercept is plus 0. We don't have to write that down. So this is just our function. F of x is equal to 11x. Then let's define our function. So x is equal to, this is where we really need to define them because x tells us nothing, right? So x is the number of, we're in minutes right now, so number of minutes. And f of x is, what does f of x mean? The amount of moonstone. Ooh, my handwriting is getting not that great. And we're doing this in pounds. LBS. I'm still always not sure about why it's LBS, but I know that it is LBS for pounds. All right, and it says determine the amount of moonstones in pounds Josiah gets if he mines moonstone for 14.7 minutes. Sounds like a very exacting number. So F of, instead of X, we're going to put in 14.7 minutes. We're evaluating the function. And then our number here is, so it's going to 11 times X. Don't write X because we're going to put in 14.7. We want to know, well, how much does it get? So we're going to go the friendly calculator, 11 times 14.7. And that's going to be 161.7 pounds, LBS. Should we be a little extra? Yes. LBS of what? Of moonstone. I want to know what moonstone is. I feel like it's going to be really pretty. I imagine it to be like turquoise, some glimmery, shimmery things. Opaly, I don't know. But anyways, so that's going to be your answer right there. All right, moving on to number 15. So Terrence, we have Terrence here. He's received a gift from his wonderful friend. Must have been a very good friend. 80 bucks. I don't know. That's a very good friend. For his birthday, so he can pay an online subscription that is $5 a month. I don't know what it is, but it's $5 a month. Write a function that describes the dollar amount of money D on the gift card after T months. So we know it's giving us what variables we need to use. We use D and T. So here we go. Remember, it's a function, so it's going to be D of T is equal to. And can write this several different ways. I feel like the way that would make the most sense is that we got 80 bucks, right? It's a one-time deal, 80 bucks on that gift card. And every time he's going to pay for this subscription, right? We want to know how much money is on there after a couple of months, right? So we're going to subtract from it. How much are we subtracting? $5 per month. So that's why we have the T, because it depends on how many months. So then we multiply the number of months that passed times 5. Then we subtract that from 80, right? And then we just keep on using it until you get to nothing, right? So there we go. That's the function. We're going to, it says to now graph it. So we're going to go and graph the guy or girl or equation function. All right, we're going to start at 80. Okay, remember, normally we start on this, it's at the end, but here 80 is the number, but it's by itself. So that's where we start. This is not necessarily function like in slope intercept form, but it is the same thing. If that bothers you, then you want to write it like this, you totally can do that. That's a T, by the way, negative 5T. Remember, because we're taking away plus. You would rather write it like that? That is A-okay. So either way, we're starting at 80. There you go, y-intercept. We're going down by 5 every day. No, sorry, every month. which means it's gonna be, so it's labeled here for 2 months. Sorry, I should probably write in here, number of months. And over here, I should write amount left. Okay, if I had more room, I would say amount left on gift card and then be like $sign. Okay, but sorry, all right. So after two months, it would be $10. They would have spent $10, right? On that. So it would have been $70 on that balance. So I'm just gonna go down like, ooh, look. Yeah, it's just nice. 4 months, it would be like another $10. 6 months, it's another $10. Keep on, I'm just gonna keep on going down. Because I know. What do I know? I know that they're gonna ask me about the X and Y intercepts. So I'm gonna definitely do that. And then I'm gonna draw my line. Okay, let's see if I can do this. Oh, look at that. Not bad. All right. And it's now asking me, label the X and Y intercepts, not the axes, the intercepts, which are completely different. The y-intercept is on the y-axis, but it is not the y-axis. So this right here, that's my y-intercept. Okay. And what does that y-intercept mean? Okay, let me go like about here. Okay, so the y-intercept, oh, let's go. I said y-intercept first, so I'm just do y-intercept. So y-intercept is 0, 80. 0, 80. What does that mean? There was, or who was this for? Terrence? We'll go with Terrence. Terrence had $80, or I should say has. I'll say started with. Terrence started with $80. I did that really weird. All right. Started is like the representative of 0. And then I'll just kind of highlight this here. See it's going around in a circle. So imagine that I'm highlighting 0 and then going with started. Ooh, I can do it. It stopped. Just kidding. Okay, I can't do it. Okay. So the 0 is the starter represents the 0, and 80 is represents the 80. All right. So I don't know. I can't do the highlighter anymore. Oh no, here it is. I can change the color, but I just well, whatever's. All right. So now we're gonna do the x-intercept. So the x-intercept we're across the x-axis, which is right here. So that this is the x-intercept, and which means the x-intercept I'm sorry, I'm running out of room down here. The x-intercept is at 16, 0. So we're going 16 to the right and it's 0 up. And which means that after after 16 months, the gift card, oh my God, gift, I can't write anymore. Okay, pretend I wrote it down. So after 16 months, the gift card has a balance of $0. That's what I'm trying to write, but it's not letting me write. Issues. I don't know. All right. So let's try this out. For Denny. So Denny has, again, a gift card, a prepaid card from his uncle, $150. Very generous uncle. Maybe that's his only nephew, right? So he can pay for a monthly gaming service for $10. Go figure. So write the amount that describes the dollar amount of D on the prepaid card after T months. So let's make this purple. Oh, apparently I can't even change the colors. That's okay. We'll just stick with green. I like green. So DFT is equal to, remember he starts with 150, and then we're going to take away $10 every month, right? So 10T. Again, if you don't like that, you could write it down like this. DFT is equal to negative 10T plus 150. Okay, just make sure that the 10 is negative. That's the big point. All right, now we're going to graph this guy. All right, we're starting at, label this first. This is the number of months. And then this is, again, I'm just going to write amount left, but it would be better if we do amount left on gift card, $. $, something like that. All right, so we're starting at 150. So notice right here, we're going by 20s. And so it goes from 140 to 160, which means 150 is right smack dab in the middle. Okay, now we're going to $10 every month, which means, and notice that this bottom is 2 months. So every 2 months is going to be double that. So it's going to be $20 every month. So we're going to go down 20. So this is 10, 20 is again halfway. I'm going to go down 20 every time. I had a ruler. And then notice right here, I can't go down 2. So if I go down 1, I have to go over, if I go down 10, I should say, I have to go over 1. So right there, right at 15. There is my line. Ah, not bad. All right, we're gonna again do the X and Y intercepts. Uh, let's see if it will let me change colors, but if not, that is okay. We will stick with green if we must, and apparently we must. So our Y intercept is right here. So Y intercept, and this is our X intercept. Okay. So our Y intercept is 0. The X is 0, and it goes all the way up to 150, which means that Denny started with under $50. Now notice I have to what is it I have to do? I have to explain it in context. You can't just be when I ask for what it means. When anyone asks, what does it mean? You can't just say, oh, it's 0, 150. Well, what does it mean? Right? And you can't just say it starts at 150. Well, okay, so Denny started with $150. You can say it like that. You can say at 0 months, he has $150. We don't technically talk like that, but you wouldn't be wrong. And then the x-intercept is going to be, this is x, 15, 0, which means after, because remember 15 means months, after 15 months, I need some more room. After 15 months, comma, he has a balance of $0. Or you can say he has no more money in his gift card. You can say he's at, yeah, something like that. But something to the effects of he has his balance of 0 on his gift card is fine. All right, after 15 months. All right. So the last two are going to be, so this next one is for people who are ML students. And if you are a multilingual learner, then this is for you. If not, skip over to like I think it's probably gonna be like the next two, these two problems. There's only 2 problems, and then your 2 will be for, so I'm gonna go through these ones, and yours is gonna be here with Noel and Sandy and Jenny and Kyle. We're gonna be comparing these 2 guys. Okay, so bear with me, or just fast forward, or just move on to the next part. Or you can do this one, but you won't see something like this on the test, but it's a good review. All right, we did this in class too, some of you. All right. So, oh, I still can't change it, but that's fine. Ooh, maybe I can just change this one. Ooh, I can. Look at that. All right. So we have two functions, right? We have function f of x and we have function g of x. So we're going to do this whole thing over here on the left, and then we're going to do the whole thing on the right, and then we're going to compare them. So here we're given the function. F of x is equal to negative 3x plus 5. In the words, we would say this function has a slope of, remember, negative 3 right here. So it's going to be negative 3, a slope of negative 3, and a y-intercept of, let's make that blue. So y-intercept of 5. You don't have to put plus 5. You can if you want to, but we just say 5 if it's positive. If it was a minus 5, then we would say negative 5. All right, now we're going to go to the graph. So we can go up. So the y-intercept is 5, so we're going to go up 5. 1, 2, 3, 4, 5. Sorry about the numbers not coming out very well, but they are going by ones. And then our y-intercept, I don't know, our, what is this called? Our slope is negative. That's how we're going to get the other points. So negative 3 means we're going to go down 3. 1, 2, 3, and then to the right 1. Just like that. Remember, it's our slope is negative 3 over 1. So we're going to go down 3 and then to the right. Again, let's do it again. 1, 2, 3, to the right 1. 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 Now let's do the opposite side, right? So instead of going down 3, we're going to go up 3. So 1, 2, 3, up, and 1 to the left. 1, 2, up. We don't have anything more left, right? So we're going to just leave it like that. And we're going to draw our line. Oh, let's see. We're going to draw our line. Go. Aha, not bad. Just like that. Now we're going to find the points. So on the table, we're going to fill out the table by looking at the graph. We look at the graph here. Ooh, at negative 2, it's supposed to be up here, plus 1 more, right? So that was at 10, 11. So I know this is going to be at 11. And at negative 1, put a negative 1 and go all the way up. And we're like, ooh, that's 8. And at 0, it's going to be 5. At 1, it's going to be 2. Notice here, minus 3, minus 3, minus 3, right? So at 2, it's going to be negative 1. At 2 minus 3 is negative 1. So there we go. We're done with function f of x. Now we're going to do g of x. Notice we have the table, but we do not have the all the other stuff, right? So we're going to go backwards. We're going to start from the table, go to the graph, and then go up to the words and then the function. So we're going to graph this negative 2, 5. So we're going to go negative 2 to the left and up 5. 1, 2, 3, 4, 5. There's my point. Negative 1, 1. So negative 1, positive. Here. Ooh, this is 0, negative 3. So I know that is my y-intercept. So I'm going to make that blue because I made my y-intercept blue. So I'm going to go 0 and then down 3. So right here. And then we're going to have 1, negative 7. So we're going to go, here's 1, and 4, 5, 6, 7. Here at negative 7. And then negative 2, 11. We can't really do that one, so that's fine. I think this will work out okay. We still know what we need to do here. And I notice here that we know our y-intercept. We know the slope, right? Because we go up. How many do we go up? We go up 1, 2, 3, 4. Up 4. And then we're going to the left 1, right? Let me draw this line right here. Oh, it's a bad line. All right. So we're going up 4 into the left 1, which means it's negative, right? Because this is a negative slope. It's downhill. So we know our slope is going to be negative 4. Okay. I should break that down a little more. So it'd be 4 over negative 1. which is going to be -4. Or slope, this function has a slope of -4 and a y-intercept of dun, 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 -3. Remember, this is our y-intercept right here. Our y-intercept right there. And then we're going to be like, let's write the function. So it's going to be not f of x, it's g of x. Look at the table. So g of x is equal to -4x. And then our y-intercept is -3. We'll go here, -3. That's our function. Now we're going to use these two functions to compare. So if we compare the, let me make it so I can see all of it. All right, so function blank has a steeper slope than function blank. So which one has it? Remember, this is not steep. This is steeper. This is steeper, right? Steeper means more up, right? So which one is steeper? Is it f of x or is it g of x? And this one we go up 4 and this one we go up 3 over 1, right? So g of x is steeper. So function g of x is steeper, has a steeper slope than function f of x. Okay, which one has a higher y-intercept? The y-intercept for f of x is 5. The y-intercept for g of x is -3. The 5 is much higher, right? Higher. And so it's going to be function f of x has a higher y-intercept than function g of x. We're going to determine which function is greater, right? Is it f of 2 or g of 2? And so f of 2, we know, we can look at it right here. F of 2 is equal to -1. G of 2 is equal to -11. Which one is greater, right? And -1 is bigger, right? So we're going to go that way. F of 2 is greater than G of 2. Ta-da, we're done. All right, we're going to go on to the next one. Practice again. Try it by yourself. If you don't know how to do it, and you can look, but you got to do it sometime. All right, well, let's try this again. This is now j of x. And so we're going to plot these points. So we're going to go -2, -5, 1, 2, 3, 4, 5. I cannot see these points here, or the numbers here is too small. -1, -3. So -1, -3 right here. And then 1, 0, -1. And I know that is the y-intercept, so I'm going to make that blue. So that's going to be 0, -1. And then 1, 1. So 1, 1. I notice the slope. Do you see the slope already? I see the slope. What are we doing? We're going up by 2, right? Up by 2, so 2 up, and then 1 to the right. So our slope is going to be 2 over 1, which is just 2. All right, I like to put in more points. Help me draw the line better and more accurate. Boom, just like that. All right, so we know that this function has a slope of 2 and our y-intercept of 0, -1. So of -1. And which means our function is going to be j of x, right? Why is it j of x? Because that's what it's called, right? So j of x is equal to 2x, and then our y-intercept is -1. There we go, just like that. And here we already have the equation or the functions, so we can just start going. We know our slope is going to be 3. So this function has a slope of 3 and a y-intercept of 1. So here we go. We're going to go with our graph. So we're going to go up 1. That's our y-intercept. And from this point, we're going to put in the other points using the slope. So remember, the slope is going to be, it's just a 3. Then we know we can put it over 1 because 3 divided by 1 is still 3. We're going to go up 3 over 1. Up 3 over 1. Up 3 1. And then the exact opposite. So we're going to go down 3 and to the left. Down 3 to the left. Down 3 to the left. Just like that. Okay, so now we're going to look at the points. So -2, at -2, y is equal to -5. At -1, y is equal to -2. At 0, y is equal to 1. I'm going to change that since that's my y-intercept. Change that to blue. Then let's go back to the other ones, our other original colors. At x equal to 1, y is equal to +4. And for 2, x is equal to, or y is equal to, +7. All right? So we're done with both sides. And so function, what has a steeper slope? This has a slope of 2. This one has a slope of 3. K is steeper. This is steeper. So k of x is steeper than, or has a steeper slope than function j of x. It has a higher y-intercept. The higher y-intercept, looks like k of x has a higher one because k is 1 and this one is -1, right? So k of x has a higher y-intercept than k of x. Now at -3, we don't have -3 here, which means we have to look on the graph. We look on the graph, we go over to 1, 2, 3, -3, and our y is going to be at -7. So this is -7. What about our k? At -3, we are going to be at -8. So k of -3 is going to be -8. So which one is greater? -7, a little bit bigger. Okay. So now we are going to go on to, so if you're an ML student, that's it. No more. You're done. Okay. But if you, now, if you are not an ML student, this is for you. We're going to be talking about Noel and Sandy. So Noel has this kind of, something's increasing, right? Sandy, okay, we should probably read this scenario, right? Sandy and Noel are practicing baking sourdough bread for a competition. Okay, so for a competition. And it looks like Sandy has already practiced baking sourdough bread 8 times. And she has decided to practice 3 times each week. So it looks like that our X is talking about the number of weeks. And then this Y is number of times practiced. Running out of room here. Right, number of times practice or number of practices. I guess we could have said that. And so Noel started with 4, looks like, and then it's going up by, this is 4, so these are going up by 2, so this would be 9, right? So from 4 to 9, that's 5. So I'm going up 5 and over, so every week. So this one, every week. So 5 practices every week. That's what it looks like Noel's doing. And then Sandy, well, we can see what she's doing, right? And so what is the y-intercept of Sandy? So Sandy, it's what she's already done, right? So this is our y-intercept. So y-intercept is going to be 0, 8. 0, 0, 8. That's the y-intercept for Sandy. Y-intercept for Noel, let's make it. So the y-intercept for Noel is going to be 4. So this is the y-intercept. B, remember B is our y-intercept, so that's going to be 0, 4. So Noel didn't start out with a whole bunch, like Sandy started out with way more, right? So it says compare the rate of change, which is the slope for both of them, right? Got to compare them. And so if you notice right here, Sandy has practiced 3 times each week, which means that this is our slope. That's our slope. And then remember we said our slope for Noel is going to be 5, which means Who's practicing more each week? Noel is, right? And how much more? 2 times more. So we're going to say, because it says compare, Noel practices 2 times more than Sandy. Gotta say who? Every week. You can't just say Noel practiced 2 times more than Sandy. This is not true. He practices 2 times more than Sandy every week. You see what I'm saying? So it is, that's how we say that it's a rate of change. And explain if the functions are decreasing, increasing, or constant. What are we doing? And Noel is increasing every time because he's getting more and more practice, right? Same thing with Sandy. Sandy's getting more and more practice too. Not as much as Noel, but she's still practicing more, right? So they are both increasing, right? Increasing because they get more and more practice. All right, so we're going to do our number 18, our last problem. So we're talking about Kyle and Jenny, and they're watching the baking show. You know what I was watching when I was writing this one? Right, Jenny and Kyle are watching all the episodes of the baking show. Both have already watched some episodes. Okay, so this is per day. Are we watching per day? Probably, right? Number of days. I guess it doesn't really say, so we could have said number of weeks. We'll be more practical, more reasonable. This is the number of episodes watched, right? Number of, I'll just say episodes. Okay, number of episodes. And so it looks like Jenny, she started with what's halfway between 8 and 12, 10. This is 10 right here. So she started out, I've already watched 10 episodes. And now she's going to watch, looks like we're going up 4, right? This is up 4 and over 1. So slope is 4. So she's watching 4 episodes in a day. Kyle started out with 15 and is watching 3 episodes a day. So what is the y-intercept of Jenny? Jenny is started out like what we said. She started out with 10. So it's just asking for some of these. Erase this guy. All right. So y-intercept of Jenny's is 10. She starts out watching 10 episodes. For Kyle, remember Kyle's y-intercept was the 15, the number that's by itself, right? So we're going to be like, Kyle's is 0, 15. It's just asking for the y-intercept. Compare the slopes. So compare the rate of change. So if we look at that, remember Jenny's was 4 because she's watching 4 every day, and Kyle's watching 3. So who's watching more? Jenny. So we'll be like, or do you want to do it less than? We'll do it greater than. So Jenny, I think normally we talk like this. Watches 1 more episode, or episode, if I can spell episode per day than Kyle. I suppose if you wanted to write, Jenny watches 1 more episode than Kyle per day. That would have probably made more sense, but that's fine. And are they decreasing, increasing, or constant? I'm going to say, yeah, they're definitely adding on to the episodes. So the both of them are increasing. Both have positive slopes. There we go. And we're done. Okay, good luck. Study well. Repeat the stuff that you need to repeat. Practice the problems again and again. That's the only way you're going to get better, right? By practicing. Have a good one. I'll see you later. As soon as I stop this, whatever that is.